Thank you for having me here. We will go a little bit higher up in the network hierarchy and discuss the convergence between vCCAP and vBNG. And there are multiple ways to achieve this type of convergence. We'll explore a few and also the reasons why operators should think about the evolution of their network and adopting virtual BNGs. The virtual CCAP is a critical component in a DAA network architecture, right? It allows cable operators to build their networks up more efficiently, and as they adopt vCCAP, you can save a lot of cost, headaches, power. You can build your network to be greener as well by adopting virtual CCAP. I don't think I have to convince anybody of the benefits of it. But at the same time, on the fiber side and fiber to the home architecture and DSL architectures, BNGs are widely deployed and widely used. And that's basically, with those network architectures, that's where all the intelligence resides. So just to kind of hit the highlights a little bit on the two types of devices. So virtual CCAP, what does it do? It plays a crucial role in DOCSIS and DAA networks. It basically takes over all the DOCSIS MAC and CMTS functions that were performed by traditional iCCAP, like the E6000 or the C100G or the Cisco CBR8, and abstracts those away into a server, right? Running effectively Linux, standard common off-the-shelf server, right? So all that DOCSIS data plane is now moved into a server. At the same time, there's a lot of intelligence that a CMTS used to do, which deals with all the subscriber management, IP allocation, IP isolation between different subscribers, ensuring that they don't their data doesn't cross into each other, that when you browse your network at home, you don't see your neighbor's network too, things like that. It also did QAM video processing and encapsulation, and routing and packet processing as well. So all those functions are now migrated towards virtual CCAP if the operator adopts a virtual CCAP architecture. On the fiber to the home side and more the legacy networks, vBNGs virtualize the core functionality of traditional BNGs. Things like user authentication, tunnel concentrating the tunnels coming in from the users, subscriber management, IP isolation, those functions that are performed by a vCCAP or by a CCAP device in the DOCSIS world are performed by a BNG in the fiber to the home world. IP address management and basic routing and packet processing, all that happens in a BNG, right? Virtualizing the BNG is just as with virtual CCAP offers significant benefits for operators. It allows them to increase scalability, improve service delivery across multiple network architectures, which is going to be the main topic of today's presentation, and obviously reduce cost. Some of the previous presenters talked a little bit about the fiber to the home evolution for operators, and I think Robert did a presentation and he was showing the results of the ATX network survey in the US, where the average duration that operators were looking at was 11.5 years for the transition to fiber to the home, right? So that is the way Commscope sees it as well, and we believe that operators, cable operators especially, because they don't need to migrate on an accelerated scale, they can continue to compete with PON and with fiber effectively using DOCSIS technologies. They can take a gradual approach to the fiber to the home introduction and migration of their network. Ultimately, I think as we all agree, 10, 20 years from now, everybody will be on fiber most likely, right? That is probably the end goal. But in the meantime, I think trying to scale a mountain, basically to climb Everest without any training, is very, very difficult, whereas a slow transition to fiber to the home allows operators to save on construction costs, save on CPE costs, and keep their core financials healthy without exposing themselves to massive risks by incurring a lot of debt and spending too much money on CapEx where it's not needed. Yes, fiber to the home is probably the end goal, but the best approach to get there is to do it gradually and efficiently over a long duration of time for cable operators. If you're a telco like Deutsche Telekom or others who have very little fiber and a lot of twisted pair, you're in a different situation, right? You need to do things fast as you can. I think one of the key differences between cable and telcos today is that cable-originated broadband traffic, broadband IP traffic, is processed in a separate silo from PON traffic today, right? Most operators, in reality, are already hybrid operators, right? If you look at, RP gave the example of Liberty Global, right? They are building fiber, transitioning their network over, building their own network to fiber, at a relatively slow pace, given the number of homes passed they have. But they have introduced PON many years ago, and they're slowly building up the amount of fiber homes they have. However, the way they process the traffic originating from the PON network is completely different from the way they process the traffic that's coming in from the cable network. Those are two different silos, right? You have CCAPs and virtual CCAPs processing the traffic coming in from the cable side and the DAA nodes. And on the other side, you have virtual BNGs, OLTs, which are relatively dumb, if I can say that. And then virtual BNGs who are performing all the more intelligent traffic management, subscriber management functions. Those are feeding right subscribers with the right IP addresses and things like that, and processing all the traffic coming in from those subscribers, which clearly, if you look at those two things, and if you're an operator that has a hybrid infrastructure, which is going to be, if not already is the case, it's going to be the case for most operators in the very short term, you need to look at that and say, okay, how can I make this thing more efficient? Because it's not exactly ideal to maintain two different silos, two different types of packet processing infrastructures in my network. There's an opportunity to increase efficiency, reduce OpEx, obviously. There's also a sort of new challenge which is more nuanced, which I call it the unified service definition and delivery, right? Where you today, even when you provision a service for a subscriber, right, on the DOCSIS side, you build a DOCSIS configuration file for a cable modem. But on the PON side, you follow a completely different process, right, and provision that in the OLT and in the vBNG. Having the ability to not only provision the service in a unified fashion across any network infrastructure that you use could be potentially very powerful, right? Because as soon as you abstract away the service definition and the service delivery, that allows you to have a more flexible approach and think of new application, things like network slicing or transporting or maintaining the quality of the service and the type of service across different network infrastructures as people move from community Wi-Fi, for example, onto the fixed network to their own home network and back, right? So those kind of things, or even to mobile, right, in the future, those kind of things are very useful as future options, but if you maintain different siloed traffic processing, it becomes exceedingly difficult to implement those service delivery and service definition elements in exactly the same way across multiple hybrid, across both cable and PON, for example. So what we believe is a possibility, and we are actually working towards that and building that into our products, is to refocus things a little bit and make the CMTS and virtual CCAP and potentially remote MAC-PHY as well, basically turn the DOCSIS part of the network and focus it on effectively the translation between Ethernet and RF, right? So almost think of it as a layer 2 network. It doesn't have to be layer 2, but it makes it easier if it is layer 2. And then the subscriber management functions and all the intelligence functions can be moved to a vBNG, even on the cable network. And that allows you to kind of build a unified type of service delivery across both cable and fiber. So if I go to the next slide, this is the situation as it would exist today, right? So you have a service provider private cloud. You have all the components necessary in this private cloud to serve both cable as well as fiber and legacy networks. So for cable, you have virtual CCAP instances, right? A virtual CCAP data plane and its corresponding standby. And the control planes that are associated with both, with virtual CCAP. You also have virtual BNGs. So you see here the virtual CCAPs and the DA nodes that are residing in the network are connected, right? So the RPD feeds its data via DEPI tunnels to the virtual CCAP data plane. If you have RMDs deployed, those can be fed straight into the vBNG data plane even today, or they can go straight to the router. The fiber part of the network is going to be fed into the vBNG, and the legacy as well, right? We'll use vBNGs to do all the intelligent traffic subscriber management. So that is kind of the siloed concept that we talked about earlier, right? Where you have separate data planes for cable and for fiber and legacy networks. And as you transition to a unified data plane, what we can do is to basically repurpose the vCCAP and basically eliminate all the functionality in the vCCAP that can be performed by a vBNG. This is basically software work. Both the vBNG and the vCCAP are essentially at the core packet processing engines, highly efficient packet processing engines. So we can move the subscriber management, we can move the IP isolation, all these functions that are currently today performed on the vCCAP, we can move them to the vBNG and let the vCCAP focus on its core function, which is DOCSIS MAC management and cable modem management, right? And leave it at that. You could think of it as make DOCSIS dumb again, but it's not quite that. It's really eliminating and trying to make things simple, right? By and approaching the network architecture in a very coherent way. So that is one option. Basically, in this case, RPDs continue to be connected to the vCCAP, but the vCCAP set of functions is reduced, and the vBNG kind of takes over a lot of the processing in the background. The next step could be to completely eliminate the virtual CCAP. You don't need that in a remote MAC-PHY architecture. With some of our products like the DC2180 node, you can actually do a software upgrade on the node itself to upgrade it from remote PHY or to migrate it from remote PHY to remote MAC-PHY. So in this situation, for example, you see that the RPD node that was there at the top, right? This guy has become RMD. The vCCAP completely disappeared. Those servers, some of them have been freed. Some of them have been converted to vBNGs, right? All the intelligent functions are now happening on vBNGs, subscriber management, all those things, IP address allocation, isolation. And this is a very transparent process for the operator, right? Because there's no need to add new infrastructure, right? The only thing you need to do to take advantage of such a convergence situation is to do a software upgrade on the node and software upgrade or license transition, license transfer on the servers from virtual CCAP to vBNG, right? And we plan to enable, we already have the node part, right? Pretty much. I think our friends at HFC Technics, our partners at HFC Technics can show you this node operating with the same RxD, we call it, in both remote Mac 5 form as well as remote 5 form. So whatever you want to deploy is available. And then the vCCAP to vBNG transfer is something that we can do as a commercial deal. We're even thinking about combining the functions into one single platform to have a combined vBNG and vCCAP, right? That you can use however you want, right? That would be a software stack that can do either and serve either architectures. We're not sure that it actually makes sense given how this looks, right, potentially in the future. And at the moment, that's under consideration. We're looking at adding that feature for the end of next year, but it's not something that we've completely decided on. However, what we have completely decided on is that we will support this type of transition and migration, right? And we will support operators who want to reuse their infrastructure that they've built on vCCAP. If they want to transition that to vBNG, that is something that we will support. And as some of you know, through the acquisition of CASA systems a few months ago, Commscope now has a very mature and well-developed virtual BNG solution, right? We were thinking and looking at building that anyway as part of our previous product set, but now with the virtual CCAP platform that we've acquired from CASA, that also came with a virtual BNG platform as well, which is highly mature. So this is a very simple and easy way to converge the two network infrastructures onto a single packet processing data plane. And it also opens up future options, which again, we can't detail too much at the moment, but we're working with chipset vendors and people like Broadcom and others to look at the DOCSIS devices and simplify them too, right? I mean, ultimately, the only thing you need here is backwards compatibility with the existing CPEs. If you can maintain that and remove everything else and move it to the BNG, that can potentially open up new possibilities in terms of making these devices smaller, more cost-effective, lower power, and moving them deeper into the network, right? So that would be maybe something we'll talk about again in a few years, okay? But I would say this is the first step towards that type of architecture. So in conclusion, today's siloed packet processing architecture is something that we need to look beyond because there are good reasons to do that. It's not efficient to maintain those two parallel silos. If you're looking for a unified packet engine, then the virtual BNG is probably the ideal solution for that because that aligns with the end state of your network, which is all fiber, say 11 and a half years from now, as we had in the survey earlier. And you can have this virtual BNG act as your unified data plane and packet processing solution for all your fixed network needs, including community Wi-Fi, if you consider that to be fixed as well. And with that comes improved efficiency, simplified operation. It allows operators to do an easier transition to things like software-defined networking and flexible service delivery, flexible service definition, network slicing, and all those sorts of things, especially if you look at business services. In that area, you need to be very flexible and have the ability to move fast. And this is an area that where BNGs and virtual BNGs especially can help a lot. And our vision is to come out with a unified service definition and subscriber management platform. And that is the virtual BNG, right? That is the end state where we see our customers' networks going. Thank you. I think I was probably a little bit faster, so we saved a bit of time.